The Constellation launch vehicle that will carry the crew into space is called Ares 1. Ares 1 consists of a shuttle-derived solid rocket booster for a lower stage and a liquid fuel rocket for an upper stage. Sitting on top of Ares 1 is the Orion Crew Exploration Vehicle. Orion is similar in shape to the Apollo spacecraft, but is larger and features state-of-the-art equipment. Orion can dock with a space station, rendezvous with other components for a lunar mission, and even be modified to play a part in a mission to Mars. All of these potential journeys depend upon the Ares 1 launch vehicle getting Orion into orbit. Like past NASA spacecraft, engineers are applying the test-as-you-go method to Ares 1. Computer analysis and early development tests begin the process. On the hardware side, parts of the rocket have been tried out individually. In the test-as-you-go world, it is time to fly, and the first flight test for Ares 1 is a vehicle called Ares 1X. It is an unmanned test and will focus on the first stage of flight.
Ares 1X is the same length as the Ares 1, the same diameter. It has a similar rocket on the bottom end, and its goal is to simulate the flight and test out the flight control to make sure that the engineers have enough data in order to finish designing and building the Ares 1.
Components for the Ares 1X have come from around the country. The rocket is being assembled at the Kennedy Space Center in Florida, the first new space vehicle in almost 3 decades. Ares 1X features a 4-segment solid rocket booster, which will lift the vehicle during its 2 minutes of powered flight. The real Ares 1 rocket will actually have a 5th segment to help push it into space. For this early test, however, the 5th segment is an inactive mock-up, as is the rest of the upper stage, crew module, and launch abort system. The Ares 1X will climb 25 miles in altitude. The first and second stage will separate. The test continues as the parachute system is deployed for the solid rocket booster, which will gently descend to the sea. From flight dynamics to control to stage recovery, the data gathered as a result of this flight will give engineers the early look they need to see how the design is progressing.
We have somewhere in the neighborhood of 700 special sensors on this rocket that we will use to collect the data on the rocket as it launches and ascends and separates and then comes back down. And the sensors are looking at pressures and temperatures and stresses and strains and vibrations and all kind of things. These are the clues that we have to what's happening at various locations along the rocket. This mission is all about, besides being cheap and quick, we're about gathering data for the Ares 1 folks for their critical design view so they can use it. Once we have that data, the Ares folks have other tests that they plan to take them higher into the atmosphere and collect more data down that way.
When we actually fly, we expect to have things that don't go perfectly. In fact, we hope they do. You learn a lot when everything goes right. You learn a tremendous amount when something doesn't go quite as right, because then you have something to go fix, to go look at, to go analyze, and then retest on a subsequent flight.